Hi everyone, I am Dr. V.S. Nishok from SNS College of Technology. In the last video, we have seen about the twin tub process under CMOS fabrication. So now, as a continuation of it, we can see the topic MOS IV characteristics under the subject VLSI design. We can see the introduction of MOSFET here. What is MOSFET? MOSFET is a metal oxide semiconductor field effect transistor, a type of transistor used to switch or amplify electrical signals. It is doing a crucial role in modern electronics, being the fundamental building blocks of digital circuits such as microprocessors, ICs, etc. The internal structure of MOSFET is shown in the below figure. So it is having a p substrate as its body terminal, and then it is connected with two n diffusion materials. So this forms a NMOS transistor. So here the terminals drain, gate and source are connected as shown. The basic structure of a MOSFET. Here we can see the components like gate, source, drain and substrate in the symbol of NMOS and PMOS transistors. So here the in the symbol of NMOS transistor, the arrow mark represents outside, that is current flowing from drain to source. So that is NMOS transistor. So PMOS represents the current flowing towards the transistor, so that is source to drain. So the two types of MOSFET transistors are N channel, that is named as NMOS transistor, and P channel, that is named as PMOS transistor. So here coming to the operating regions of MOSFET. So we are having three different operating regions: cutoff region, that is nearer to x-axis, and linear region, that is nearer to y-axis, and active region, that is almost saturation region, that is at the center between the x and y-axis. The cutoff region. So if you see the cutoff region, the MOSFET is mostly in off condition because there is no current flow between the drain and source. Coming to the triode region, it is otherwise called as a linear region. The MOSFET acts as a variable resistor. The current flow is controlled by the gate voltage. And coming to the saturation region, the MOSFET is fully on. The current is nearly independent of the drain source voltage. So starting with cutoff region, so here if you see the diagram, between the two n-type materials, there is no channel formed, and there is no, if there is no channel, there won't be any flow of current between the source and drain. So default the current flow will be 0. IDS will be considered as 0 in the cutoff region. And then coming to the linear region. So if you see here in the diagram, between the two n-type material, there is a channel formed through which the current flow takes place from drain to source. Similarly, coming to the saturation region, that is otherwise called as active region, here the channel starts to pinch off. That is based on the several parameters, deviations of the several parameters, the channel starts to reduce. Okay, based on the drain current maybe. So if the drain current keep on increasing, the channel starts to reduce. If the channel is reduced, then the flow of current also will be affected. Coming to the IV characteristics. So what is IV? I represents the current and V represents the voltage. So what about the variations of the current based on the voltages inside the circuit? So that is named as a IV characteristics of MOSFET transistors. So here we are considering a typical structure of NMOS transistor as shown in the figure. So if there is no current flow in cutoff region, then your current will be 0. So we are not considering that cutoff region. We are starting the IV characteristics with linear region. So in linear region, IDS depends on how much charge is in the channel and how fast the charge is moving in the channel. So that is charge represented by Q, and that is transit time of the charge, that is represented by T or tau. So the equations are given here in this slide. Q channel, which is equal to C into V. So the respective equations are given here. So the charge is calculated along with the help of capacitance, and the voltages like VGS and VDS and threshold voltage VT. Similarly, the transit time, that is time for carrier to cross the channel, that is given as T, which is equal to L by V. L is the length of the channel and V represents the velocity of the electrons. So by substituting this equation, so IDS is calculated with the help of Q channel by T equation. So by substituting the above equations here, we will obtain IDS is equal to in terms of beta and into VGS minus VT minus VDS by 2 into VDS. So this is your final current equation for linear region. So coming to the NMOS saturation region, here, as seen earlier, channel starts to pinch off when VDS equal to VGS minus VT. So now drain voltage no longer increase the current. So in the saturation region, there is no linear increase in the current based on the voltage. So it reaches maximum height and it maintains constant throughout the increase in the voltage. So that is mentioned here in the NMOS saturation region. So see, up to now we have seen about the NMOS structure. So for PMOS structure, what is the IV characteristics? That is nothing but, so all the doping and voltages are inverted. So that is polarities are reverse, that's all. That is same characteristics followed by the PMOS. So here this is the summary of first order transistor model. That is nothing but, so ideal IV characteristics of MOSFET is otherwise called as first order transistor model. So for cutoff region, so as we discussed, three regions are there. For cutoff region, IDS will be equal to 0, and for linear region we are having IDS value as derived beta into VGS minus VT minus VDS by 2 into VDS when the condition VDS is less than saturation voltage. Similarly, in the saturation region we are having IDS equal to beta by 2 into VGS minus VT the whole square. So this is the final equation for current in the ideal condition of MOSFET. So here we can see the plot representing current and voltage of the MOSFET transistor, that is especially in the NMOS transistor. So x-axis is represented by VDS and y-axis is represented by IDS. So here when the VGS, so that is gate, that is voltage given to the gate of the NMOS transistor, if we are keep on gradually increasing, in the initial stage the current also starts to increase linearly with the increase in the VGS value. So after attaining the certain stage, that is after reaching the active region, then it starts to move constant. There is no increase in the current. So that is shown clearly in this plot. So coming to the assessment questions. So what are the three operating regions of the MOSFET is your first question, and write the IDS equation for three models in the Shockley first order transistor model, and first order represents here the ideal IV characteristics, and then draw the PMOS IV plot. So these are all your assessment questions. So in this video we have seen about the introduction to MOSFET and what are the regions the MOSFET transistor is working, and we have taken an NMOS transistor as an example, and for different regions what is the current value vary, that is IDS value vary based on the variation in the given input voltage. So those things we have discussed, and its final plot, that is saying current is increasing up to some level in a linear range, and it reaches the saturation when it reaches the saturation region. So that is we have seen through the plot. So in the next video we can see the another topic. Thank you.